Hi everyone. Today I want to share what I've learned about implementing private connectivity in AWS, which is especially important in enterprise environments. When I started working with AWS, I found this topic a bit confusing, so I'm hoping this demo will make it clearer for you. By default, most AWS services like Lambda, RDS, and S3 are publicly accessible. Think of it like a building and there's a public entrance, so anyone can walk through it. In AWS, this means your service has an endpoint that's open from the internet. In enterprise environments, though, you typically don't want critical services to be publicly accessible. It's like having confidential information in your office that anyone can walk through. That's where private connectivity comes in. When we make an AWS service private, we're restricting access to it. When we're talking about access, it can be restricted on who, the identity, and how, the network. For this demo, we're focused on restricting the network connectivity. Instead of a public door, we create a private one. In AWS, this is done through VPC endpoints and AWS Private Link. Something that confused me initially was the distinction between inbound and outbound traffic and where you configure this on a cloud service. I thought it was just enabling private access in one place, and that's it. Private endpoints primarily control inbound traffic, connections going into your service. So by default, outbound connections from your service still go through the public internet. However, just like in Azure, once a connection is established through that private endpoint, the ongoing session maintains that private path for consistent security. I'll demonstrate this with a Lambda function and API gateway, which works well for this demo because it clearly shows both inbound and outbound connectivity patterns. We'll start with a public app, then implement private access and control outbound traffic with a NAT gateway. I've already deployed our base environment using CloudFormation, and I'd just like to point out two of the main resources here, which is our API gateway and the Lambda function. So the Lambda function hosts the application code, and the API gateway is the front end where my calls from the internet comes from. So it's the first point of contact from external access from the internet, and the API gateway has the smarts of routing that traffic to my Lambda function. So we have our API gateway, our Lambda. This is where our application is hosted. We've got the internet here, and we've got finally our laptop. So the application is accessible from my home via this API gateway. This is saying that the IP address that my Lambda function is picking up is this IP address, and this IP address is actually my internet service provider's IP address. If I click on check outbound IP address here, this outbound IP address is the Lambda function's IP address that it gets from AWS managed Lambda service. And this IP address can change. So going back to our whiteboard, this is what the flow looks like. From my home, I am accessing this application via this API gateway, and I'm using the internet via this public IP address of my ISP. And then when I click on the check outbound IP address of my Lambda app, my Lambda app makes a call to this server on the internet, ifconfig.me/IP, and it uses this IP address that is managed by AWS, meaning I don't have any control over it. Now I'm going to deploy the private version of my application via CloudFormation again. And don't worry, I'm going to share all the code on GitHub, where you can have all the time to go over the code. The private version looks like this now. The private version now removes internet access, and I shouldn't be able to access my API gateway anymore from the internet. And then the Lambda application should not be using the AWS managed IP address. I've finished redeploying my CloudFormation template to make it private. And as you can see, there's a bunch more of resources in here. There's VPCs, there's subnets, there's routes, there's security groups. So a lot of networking components that we can see in here. And I'll describe them more in detail. But first, we'll just test that I should not be able to access this application anymore from my home. So if I refresh this page, I now get, you can't access this. So that's expected, and that's good. I will access this application through a virtual machine EC2 instance that I've deployed within the same VPC, and I'll describe to you better through this whiteboard. So this is what the private architecture looks like. I've got my EC2 instance in that same private subnet as the API gateway and the Lambda. I've also deployed a NAT gateway and I've put it in the public subnet. All of them are located within the same VPC. I'm now going to EC2 and connect to it through Session Manager. I'm going to make a curl call from this EC2 instance. And as we can see, we have our internal IP address. So our Lambda function now is recording the source IP address of the machine calling it is within the private subnet. If we now make a curl call to the get my IP URL, we can see that the outbound IP address is different. Going back to the whiteboard, hopefully the whiteboard gives you a clearer picture of what's going on and what the corresponding IP addresses that we can see in the terminal here, the 10.0.2.239. So that's the IP address of my EC2 instance. When it hits the Lambda application just displays this IP address as the source IP address. Then when it tries to get the IP address of the outbound traffic, it goes to this server ifconfig.me and it's recording that it's using 54.253.85.69 IP address. That's different to the outbound IP address that we were seeing before we've made it into private without the NAT gateway. This is important because the 54.253.85.69 address, that actually represents an elastic IP service that we've created as part of this private deployment. And now we have control over this IP address. We know what it is. It is static. And that's something we can configure on external calls that our Lambda is making. For example, it's making a call to a secure service that needs to whitelist my IP address. Then I can give them this public IP, and I know that won't change unless I delete and recreate my elastic IP service. One thing I forgot to mention in this diagram is the VPC endpoint. So between my EC2 and the API gateway, there is what we call a VPC endpoint that is deployed and associated with the API gateway. This means that my calls to the API gateway from my EC2, I hit the VPC endpoint first, and that VPC endpoint is mapped to the API gateway. And this is what makes the data flow all private via this VPC endpoint that is powered by Private Link. I forgot to mention our VPC endpoint. So in our earlier diagram, I inserted this VPC endpoint between our EC2 and API gateway. My calls to the API gateway actually goes through a VPC endpoint that is associated to the API gateway. This is just a simple environment to demonstrate the configurations that you need to consider when you want to have an application that is fully private. Obviously, in a real enterprise environment, there would be additional security layers. In the front end, you would have an AWS WAF for application protection, and you can have AWS Shield for DDoS protection, For its outbound access, you can have network firewalls for traffic inspection, like a proxy, and also you'd have a transit gateway for connecting multiple VPCs. I might not have my NAT gateway sitting in the public subnet in the same VPC as my Lambda. Usually you'd have them in separate VPCs or even on-prem. You'd also have access controls. You can use federated identity provider, IAM roles with least privilege, resource policies for service access, private hosted zones for DNS, and the list goes on and on. There's so many other things to consider to make this enterprise ready. But the main point of this demonstration is to show the network connectivity, at least just to make it clearer, both inbound and outbound access of your application service and how you configure that. I had to redeploy the environment because I forgot to walk you through the AWS console. So as you can see, the first one that's deleted, that shows the 54.253 address that we were seeing when we were doing the get my IP call. And this is the NAT gateway. For the API gateway, we can see here that it's hooked up to this VPC endpoint. And if I go to the VPC console, to the endpoint, we can see there is a security group hooked up to it. With that security group, inbound rules, it only accepts HTTPS traffic when it's coming from the VPC. For outbound, it's allowed all outbound access. So we're only restricting inbound so that our VPC endpoint will only accept HTTPS traffic and only if it's coming from within the CIDR range of our VPC. You can see the API endpoint type is private. And another thing with the API gateway is the resource policy. This controls what can access the API gateway. The first rule allowing the action execute API invoke, this says who can invoke this resource. The resource is this random number which maps to my API gateway. And it's saying deny all actions of execute API invoke except when it's coming from the VPC endpoint. And this is the VPC endpoint. This is the VPC endpoint. That's how we restrict access to the API gateway. A combination of this resource policy and hooking it up to this VPC endpoint, which has security group inbound restrictions as well. For the function, we didn't need to create a VPC endpoint for this because we've made our Lambda function into a private one. We have included it into the VPC. So by default, by making our Lambda function part of the VPC, it won't accept any traffic from the internet. All the traffic between the API gateway and the Lambda function are just contained within the VPC. To summarize what we've learned, we started with a publicly accessible Lambda function and API gateway. This is similar to how many of us initially deploy our applications for simplicity and to check that it works. Then we implemented private connectivity using private VPC with isolated subnets, and we made our API gateway private by hooking it up to a VPC endpoint. Also, our Lambda, we've put it into the VPC. We use the NAT gateway to control our outbound internet access, and so that our internet access would be coming from that single IP address that we control and that we manage. Next, we've seen how we can test private access using a virtual machine within the same VPC as our application. We've also seen how VPC endpoints are used for private access. Then we've seen how we can control that outbound internet access. We discussed additional enterprise security features that would be implemented in a real-world scenario. This setup provides a secure way to host applications in AWS while maintaining control over both inbound and outbound traffic, exactly what enterprise security teams look for. Understanding the difference between public and private connectivity, that's crucial for properly securing our resources in AWS. It's like knowing the difference between having a public storefront and a secure back office. In a real enterprise environment, you'll need to carefully plan your network architecture to balance security requirements with application functionality. The techniques we've covered give you some of the tools to implement proper network security for your AWS applications. Thanks for watching, and I hope this helps you better understand how to secure your resources in AWS.